Did you know that Jupiter's Great Red Spot is so big that Earth would get lost in it? Or that this massive storm has been raging for at least 300 years and scientists still don't know why? They do, however, have some theories. And if you want to hear them, stick around because today we will be talking about Jupiter's Great Red Spot. How does it work? Why won't it stop? And could something similar happen here on Earth? This is our channel. And today we're answering the extraordinary question, why doesn't Jupiter's Great Red Spot ever end? We are starting with our top geographies. Number 1, United States. If you grew up here, chances are you learned about the Great Red Spot when you were just a wee young thing.
Back in school.
They probably taught you that the Great Red Spot is a massive high-pressure storm rising above Jupiter's surface. They also taught you that its winds can reach speeds of more than 600 miles per hour. And if that didn't blow your mind enough, they probably also told you that the storm is wide enough to swallow Earth whole. So let's take a moment to really wrap our heads around this. Imagine taking an object as large as our entire planet and dropping it into a never-ending maelstrom of violently swirling gas. Yeah, that's terrifying. But what exactly is happening down there? We'll tell you right after. No. Point 2, United Kingdom. As frightening as the thought of getting sucked into Jupiter's Great Red Spot might be, there's no need to worry. The last time Earth passed through the orbit of Jupiter, it happened in 1992, but don't take any chances. If you do find yourself hurtling towards the giant gas planet anytime soon, here's how you can survive it. Okay, first off, suck in a deep breath and try to keep calm. Next, make sure your space shuttle is equipped with a heat shield. Then brace yourself for temperatures as high as 3,000 degrees Fahrenheit. It's also a good idea to bring a spacesuit just in case your shuttle's heat shield fails. Finally, once you get close to the planet, protect your ears because you'll experience noises louder than a rocket launch. Now you're welcome.
Oh.
Now let's move on. You may be wondering why we chose these two particular countries for this episode. Well, back in 2012, NASA held a competition asking people around the world to submit their questions about Jupiter's Great Red Spot. Some of the best questions came from the US and the UK, so we decided to highlight them. Plus, both countries have had active roles in the search to unravel the mysteries of the Great Red Spot. For example, NASA's Juno spacecraft has been orbiting Jupiter since 2016. One of its missions is to study the planet's atmosphere and magnetosphere, which includes the Great Red Spot. Meanwhile, the UK's radio telescope at Jodrell Bank has been observing Jupiter since the 1970s. Scientists have used the telescope to track changes in the planet's atmosphere over time, including the Great Red Spot. Now back to the show. Number 3. What is it? Despite all the observations and scientific endeavors, we still don't know exactly what causes Jupiter's Great Red Spot. What we do know is that it is a high-pressure storm that has been raging on the planet for at least 300 years. The storm is located about 22 degrees south of Jupiter's equator, and it is wide enough to fit 3 Earths side by side. But despite its immense size, the storm isn't all that tall. In fact, it only rises 3 miles above Jupiter's surface. Scientists think that the storm gets its energy from the planet's internal heat. Jupiter radiates more heat than it receives from the sun, and that extra heat comes from the planet's core. Scientists aren't sure what's at the core of Jupiter, but they think it could be a giant ball of rock and metal. As the planet's core releases heat, it creates convection currents in the planet's atmosphere. These currents cause gases like hydrogen and helium to rise and fall, which creates turbulence and eventually forms clouds. And that's where storms like the Great Red Spot come in. But why is it red? Nobody knows for sure, but one theory is that the reddish color comes from phosphine. Here on Earth, phosphine is a rare substance that's only found in small amounts. But on Jupiter, phosphine could be more abundant. When exposed to sunlight, it could react to produce red light. Another possibility is that the color comes from organic molecules that are produced when sunlight hits ammonia ice crystals. Whatever the cause, the color has remained a mystery since Galileo Galilei first observed the storm in 1664. Number 4, how does it work? Now that we know what fuels the storm, let's talk about how it works. High-altitude winds on Jupiter blow counterclockwise around the equator, but at lower altitudes, the winds blow clockwise. When these winds meet, they form a gigantic whirlpool. The Great Red Spot is essentially a giant whirlpool. As the winds converge on the Great Red Spot, they speed up and form a narrow band around the center of the storm. This band acts like a wall that keeps the storm from expanding. As the winds continue to spin faster and faster, they form a vortex that sucks in more and more air. Eventually, the air reaches a point where it can no longer support itself and it collapses. This creates a powerful explosion that sends debris flying outward. The debris forms another band around the storm, which adds to the height of the vortex. This process repeats itself over and over again. It's creating a never-ending cycle of rising air, speeding winds, and outward explosions. No 5, why doesn't it stop? Now let's answer the question that's been keeping us up at night. Why won't the storm ever end? Scientists think that the Great Red Spot will continue to rage for millions of years. That's because the planet's internal heat will likely continue to fuel the storm. And as long as the storm is fueled, it will continue to grow in size and intensity. In fact, the Great Red Spot is already bigger than it was 300 years ago. Scientists have observed that the storm has been growing by about 100 miles per year. At that rate, the storm will be big enough to swallow Earth twice by the year 2200. Number 6. Could it happen here? Now that we know how powerful Jupiter's Great Red Spot is, you might be wondering if something similar could happen here on Earth. The good news is that it can't. The bad news is that it can't. Let us explain. First off, Earth is a lot smaller than Jupiter. To form a storm as big as the Great Red Spot on Earth, we would need a planet about 10 times larger than Jupiter. It's not going to happen. Second, the atmosphere of Earth is a lot thinner than that of Jupiter. On Jupiter, the atmosphere is mostly made up of hydrogen and helium, which are gases that can reach extremely high altitudes. On Earth, the atmosphere is mostly made up of nitrogen and oxygen, which can't reach those same heights. Third, Earth's rotation is a lot faster than Jupiter's. The planet's rotation creates the Coriolis effect, which causes moving objects to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. The Coriolis effect is what keeps the Great Red Spot from expanding beyond Jupiter's surface. But Earth's faster rotation means that any storm that formed here would be torn apart by the Coriolis effect before it could grow very large. Finally, Earth's magnetic field protects us from the solar wind, which is a stream of charged particles that flows out from the sun. The solar wind can disrupt the atmosphere of planets and even knock satellites out of orbit. But thanks to our magnetic field, we are protected from its effects. In other words, the conditions that allow Jupiter's Great Red Spot to thrive are not present on Earth, so rest easy. You're safe from giant red spots for now. If you enjoyed this episode and want to learn more about our amazing planet, check out our video on Why Does Earth Have Seasons? Thanks for watching.